I'm Roger Pенrouz. I'm the Emeritus Rouse Ball Professor of Mathematics at the University of Oxford. I've been interested in issues to do with consciousness and its connection with deep issues in physics for many years. I certainly hope that this conference will be an opportunity to convey ideas of deep importance in how science is trying to grapple with these questions of consciousness and to promote these ideas to the general public and the arguments that go on between different points of view, which will go on and which must go on for a long time to come. There is a current view that consciousness is something which arises from some complicated computation. So we have our computers, and people think that because they can do things amazingly fast and they can calculate very quickly and they can play chess extremely well, that they're superior to us even, and that it's only that some complicated aspect of this computational activity, somehow consciousness arises from that. Now my view is quite different from this. I think there is a lot of computational activity going on in the brain, but this is basically unconscious. So consciousness seems to me to be something quite different. What we do when we understand something is not computing. There's something else going on. But at the same time, I'm a great believer in science, and that what's going on in our heads is still obeying the same laws that are going on in the universe outside us. However, those laws are not things that we necessarily fully understand today. To be understanding something, you need to be aware of it. And to be aware of it, you're conscious of it. And so you are invoking your consciousness. So to me, there is something outside the computational laws of physics. And when I wrote my book, The Emperor's New Mind, I was trying to develop this idea, and I was trying to say, well, there is something else out there. What could it be? Where is the biggest gap in our understanding of physics? There are lots of gaps in, we don't know what governs the masses of particles. We don't know all sorts of detailed things. But most of these things don't have a direct bearing on what a brain does. I mean, it's the wrong scale. There is a big gap in our understanding of the laws, and this big gap is within present-day quantum mechanics. There are two procedures in quantum mechanics, the Schrödinger equation and the making of the measurement, and they're inconsistent. I say it quite strongly. It's not just that we haven't got the right interpretation of quantum mechanics, they're just inconsistent. Now that's interesting. If there was a huge gap, maybe that gap is where the theory has to be outside a computational system. Okay, this is, many people will dispute that and they say, well, this is, taking your logic too far and so on. Well, it seems to me there is logic in this. The next step, though, is the one that people mostly question. Because if inside our heads we are exploiting that gap, it means that we have quantum development in the system which takes us to a level somewhat beyond present technology in our experiments. The experiments still support quantum mechanics, and we have not yet seen where something new has to come in. But there are good reasons, in my opinion, when we look at going back to these two major revolutions of 20th century physics, quantum mechanics on the one hand, Einstein's theory of general relativity, space-time is not flat, it's curved, gravity is not a force, it's somehow a curvature. There is something quite different from other kinds of physics going on there. If you bring these two great theories together, we see this conflict suggests strongly that there must be a change in the rules of quantum mechanics at a certain level. And that certain level is not too unreasonable that it should be relevant in the brain, because it has to do with the movement of mass of a very tiny amount. It's very big for quantum mechanical experiments, but very tiny even for things in biology. So we're looking for tiny displacements of mass. That's the Schrödinger's cat, if you like. They can be in two places at the same time, but then it spontaneously becomes one or the other. And in its becoming one or the other, it's doing something non-computational. Now, when I wrote The Emperor's New Mind, I knew something about nerve propagation, and it just didn't seem to me there's a chance. There's no chance, because in nerve propagation, it disturbs the rest of the brain in a way which would completely destroy the coherence that you would need in your quantum system to be able to probe this new level in quantum mechanics. But still, I thought, when I finished writing the book, maybe I will see the answer. No, I didn't. But the answer, in a certain sense, may have come because Stuart Hameroff read my book, and he contacted me and said, well, look, maybe you don't know about these things in the brain, these microtubules. And I thought, microtubules, what's that? In my ignorance, I didn't know about them. If I had, I might have said, well, maybe that's a good place to look. And it seemed to me that was a much better place to look. You could conceivably imagine the kind of isolation that was necessary. It still goes beyond normal people's understanding of the kind of isolation you would expect to find in a cell, but there is a reasonable chance. And since it happens, since we are conscious, we can understand things, we seem to do things which go beyond a purely computational activity, the logic is, well, maybe this is in the microtubules, because that's the best candidate I've ever seen. And so we got together, and the ideas we then developed from there. My ideas came from the physics and from my desire, the feeling that in order to understand consciousness, we need this kind of level of coherent quantum mechanics, and that the state reduction has to come in. So it's the idea of the OR, if you like, has to be part of the scheme. But then exactly why, what part of the brain's involved, and where, what is the neurochemistry, what are the structures in the brain, that's all Stuart. So mine is on the physics side, and his is on the biological side.